and the third lecture. So working with rasters, vectors, and tables. So let's go. So vector dataset. As you remember that our vector dataset can be either points, lines, or polygons. So vector data model is an object-based description of the real world. So it contains from the geometric objects. Geographic phenomena are represented as points, lines, or polygon features. A collection of features of one type with the same attributes and spatial reference, often referred to as a feature class by ArcGIS, are stored in a vector dataset, the shapefile, with the extension of shapefile. Attribute data associated to features are stored in tables. Each feature has one record entry in the table. Each field column describes a particular attribute. So actually, attribute is the name of a column. In the case of a shapefile, the attribute data are saved in a dbase table file in a dbf extension. So creating vector dataset. So if your data consists of features too small to be depicted either as lines or areas, then you should create an ArcMap point dataset. Point represent discrete locations such as wells, shops, telephone booths, and etc. So if your object you're going to represent is too small, it's better to work with the point features. For representation of certain real-life objects, different vector types can be used. For example, for representing roads, trails, and pedestrian path, line vector structure is the most appropriate. For showing more complex real-life phenomena such as nature reserves, country, shape, or real estate polygon, features are commonly used. So if you cannot use a point, you should use either a line or a polygon dataset. Mostly the most used polygon, the most used type of vector is a polygon shapefile. So with the polygon, you can just represent almost all geographic phenomena. So editing attribute table of vector dataset. Initially, the attribute table will contain two fields called FID and shape, so they are given by the ArcMap. The FID field contains unique identifiers of the features in the vector dataset. The unique identifier links the thematic attribute data to the geometry of a geographic feature. So each object, geographic object like point, line, or polygon has its FID, and via this FID, the object is linked to its attributes. In ArcGIS, these unique identifiers cannot be changed, whereas in the ID field, a user-defined identifier can be stored. So you can create your own ID field and change it manually. The shape field stores the feature type of the geographic features, points, lines, or polygons. This field is maintained by ArcMap and cannot be edited. So when you create, while you're creating a new feature dataset with ArcToolbox, you should always mention either you're creating a point, line, or polygon. We will talk about it in the third tutorial when we create a new vector dataset. And with this option, with this line, ArcGIS automatically gives a new dataset to within an attribute table. Dataset shape. Attribute table can be edited at any time by adding or deleting fields, columns, and records objects. So you can create, you can add or delete either a column or you can or a record objects. When you create new fields in an attribute table, you must select a data type for that field. So we remember from the first tutorial, it can be integer, float, long integer, short integer, a double, text, and date. The data type determines the kind of data, for example, text and number, that can be stored in a field. You cannot write or store another data type in this field if you mentioned another data type. So ArcMap supports several data types, but the most important ones are float, integer, text, and date. So important. Never use blank spaces and symbols in the attribute names, only letters, numbers, and underscores. Attribute names can only be 10 characters long, so you cannot write more than 10 characters, and never use blank spaces and never use blank spaces. Anyway, ArcMap will not register it, and the error window will occur in this case. When adding or deleting fields or rows in a table, make sure that the table itself is not open and not in edit mode. So we'll talk about it in our tutorial. Calculating the area of polygon features. So in ArcMap, you can calculate the area of the polygon features of a dataset. There are 3 ways to do this: with ArcMap, with ArcToolbox, with the field calculator, and the calculate geometry option. So we will talk about all of these options in our tutorial in a practical video. So we can always calculate the area of a polygon you created. For polygons, the most fast and convenient way is to use calculate geometry tool in attribute table. Yes, it's most convenient. In some cases, you can use field calculator in ArcToolbox. Actually, calculate geometry is mostly used for vector polygons, vector datasets, while field calculator is used to calculate various attributes of a raster dataset. We will use both of them, and you will understand which one is the most feasible and which in certain cases. Creating a new table. So in ArcMap, you have option to create attribute table without geospatial information. This can be done via ArcToolbox. If your tabular data is stored on the hard drive of your computer yet, creating a new table is a good way to get it into ArcMap. So by putting your data in a separate table, you can work with it independently from any particular dataset, and you can join it to any appropriate dataset whenever you want it. So again, we will work on joining different tables according to their similar attributes. And also you can make a table, attribute table in ArcMap with your Excel file. So raster datasets. So raster datasets contain from cells. So you can see here cells with different values, and each cell called the pixel has its own resolution. So raster dataset is another widely used type of spatial data in ArcGIS. Raster dataset is considered as location-based data structure. If vector dataset is object-based, the raster dataset is location-based. Remember this. It contains of cells named pixels with a certain value, integer or float. Here you can see that mostly in this case integer values. All pixels have the same size, pixel resolution. So all the pixels are grids and have the same size. So raster type, there are 2 types of rasters. First, the discrete raster, and this, here we can see the discrete raster. When the pixels are clearly distinguished from each other, for instance, agriculture, background, water. So here is the land use classes. And the second is continuous raster. It's here we can see that actually pixel values of slowly change from one to another. Discrete rasters always have the integer values, while continuous has the float values of pixels. Discrete raster always has the attribute table, while continuous raster doesn't have an attribute table. You should remember this. Discrete raster represents geographic features that have definable boundaries, sometimes referred to as categorical or discontinuous data. Examples of this discrete are lake, forests, lands, buildings, roads, etc. Continuous rasters represent geographic phenomena that vary spatial without discrete steps, so very spatial, right? Do not have distinct boundaries, and a geographic feature such as lakes has a real and definable boundary. So it's not a continuous. Potential each cell in a continuous raster can have a different value. Examples: temperature, precipitation, vegetation index, such as in the so it's spatially vary and without discrete steps. So zone and region. Raster cells that share the same value represent the same type of geographic object. Cluster of contiguous raster cells with the same value are called a region, while a region represented a discrete geographic object, building, or a lake. All regions with the same value make up a zone. Zones represent all geographic objects with the same value, for instance, buildings or lakes. So zones actually are raster classes. So we can see we represent a zone. Hey guys, if you liked the video, please consider supporting the channel by purchasing online courses via my Udemy's profile, GIS Lab. Here you can find multiple courses regarding GIS remote sensing. The link to the profile is below.